Welcome to the latest episode of the DC webcasts. Today we are going to be talking about the impact of AI in the training and simulation industry. I'm your host, Gareth Harwood, Director of Marketing at Dedicated Computing. We're joined today by two subject matter experts, Carl Flygare from PNY Technology. Carl is the NVIDIA Quadro Product Marketing Manager. Carl's got over 25 years in the industry. We're really lucky to have Carl here today. We're also joined by Jeff Krueger from Dedicated Computing. Jeff is our Director of Systems Engineering, who works very closely with many of our large OEMs in the training and sim space. Jeff, we'll start with you. So Dedicated, like I said, is helping many of the world's largest OEMs, flight simulation, ground simulation. What are you seeing out there as it relates to AI, machine learning, and other emerging technologies? There's a lot going on out there.
Yes, thank you, Gareth. Well, one of the goals of a training and sim provider is to create high fidelity, immersive environments. And AI and some of the NVIDIA GPU technology is finally starting to be able to do that. From an AI-based approach, it's helping create the worlds, the modeling aspects of it at a richer and deeper method. And it's also creating an environment that's based more on our physical world, so it's more realistic. A specific bomb going off, we know how that works in the real world, and AI can generate the visual scenery for that based on the physics of the real world, instead of having to model and understand that via software. In the past, the large amounts of data to produce real-time ray tracing really held that back. Rasterization has always been the means by which we deliver a lot of the training sim today, but some of the NVIDIA technology that's allowing for real-time frame rates are allowing ray tracing to be incorporated into a game-like environment. In the past, one other area of slight shift is a lot of these developers relied heavily on their proprietary physics engine, a lot of incorporating into the GPUs at a lower level, but with ray tracing coming along, do you still want to be able to do that? If you want to move up a layer in the stack and start focusing on game type physics engines that have already proved out ray tracing on specific GPUs, to move away from tying into anything specific to the GPU. So at a higher level, the solution developer can now focus more on the software-based capability of their product, and not so much all the underlying activity from which they've done in the past. And a lot of the NVIDIA GPUs are allowing these folks to advance their solution at a much greater pace than in the past.
Great. Yeah, it seems to be changing quickly. Thank you, Jeff. As we transition over to Carl, so the bulk of this webcast, Carl, great input on NVIDIA, Quadro, got some roadmap information, some product information, but as it relates to training and sim, let's start there. What do you see out there, and give us a view of the landscape in the modeling and simulation and training market?
Well, thank you so much for that lead-in. I think the area where I'd like to start is the whole concept of ray tracing. It's been the holy grail of computer graphics for decades. And the fact of the matter is, only ray tracing can model the behavior of real materials and light in 3D space. It's intensely compute intensive. It has not been able to be done in real time until now. With Quadro RTX, we have the ability to do real-time ray tracing, which can, in simulation or visualization content, deliver cinematic quality real-time imagery. This is a huge step, and it's coming to market nearly 5 years quicker than anyone thought, according to John Petty, the principal and lead researcher at John Petty Research. And this is all due to Quadro RTX technology. Quadro RTX brings together what you need to do today's viz and sim environments. It brings together ray tracing, deep learning, which is the AI component, and advanced shading, all in a single GPU, something that's never been done before. RT cores deliver real-time ray tracing at 25 times the speed of the prior generation Pascal GPUs, and can render cinematic quality effects at 30x CPU speeds. Tensor cores can go in and denoise those ray tracings. So instead of having to do a couple hundred iterations, the image can pop and look photorealistic in, say, 10. You can take a lower quality image and scale it up using AI. You can retime video, shoot it at 30 frames, play it back at 120, all through artificial intelligence. So huge implications here for visualization simulation. Of course, in many instances, you may want to use the traditional rasterization rendering model. RTX implements a hybrid. You can choose RT, ray tracing when you need it, drop back to the traditional rasterization approaches when they're more effective. So let's get into the real time, the ray tracing. Here's an example of a partial visualization of a home. It's not bad. I mean, it would have been rather nice 3 or 4 years ago, but it lacks realism. And if you're trying to simulate an environment, particularly for very demanding users like the military, for example, or medical applications, or even scientific research, it simply lacks the realism required for simulation. Would you rather have this or that? Well, that's what Quadro RTX GPUs bring to the party. They have the ability to render reality because it is truly physically based rendering. We're not in game parlance utilizing any cheats to make life easier. We're actually doing the heavy lifting required to deliver completely photorealistic, physical reality-based images. Here's an example of ray tracing. Right now, ray tracing is not on. Watch what happens when it turns on. You see all of a sudden a whole bunch of reflections in that chrome pillar that simply weren't there before. Now RTX is off. RTX off would have been the best you could do prior to Quadro RTX unless you were willing to spend dozens and dozens of hours rendering this stuff on CPUs or investing in very expensive CPU render farms to do it quickly. With RTX, it can be done in real time. Also, what's simulated versus what's real? Again, if you're talking cutting-edge, state-of-the-art simulation, you should be able to reproduce an environment that to participants appears to be real. I'm using 2 interiors of the building here. Which one is which? One is a photograph taken with a digital SLR. The other is the same thing rendered. Well, it turns out the image on the right was rendered on a Quadro RTX. The image on the left was a photo shot with a digital SLR. They are indistinguishable from one another. CPUs simply provide the kind of performance advantage required to make ray tracing viable in simulation environments. Now, I don't expect this will be completely fluid. I'm showing the relative performance of an Intel Core i7-7900X relative to a Quadro RTX GPU, in this case an RTX 4000 card. And the CPU has yet to render a single image, while the RTX card has almost finished the turntable. I'm taking this image and trying to rotate it 360 degrees. And the Quadro RTX is basically done. The CPU is still rendering the first frame. So you can see the huge implications this has for performance and the ability to deliver ray tracing in real-time simulation environments. If you create videos for training or use them as part of your simulation, it's a very complex multi-phase workflow. I'm not going to delve through this in a lot of detail, but you have pre-production, asset creation, you need to clean it up, you need to do your shots, and then you need to finish it. And it's a complex product. Rendering actually plays a role in this process, which leads to the finished video product. ranging from previs to modeling. If you're dealing with human beings, fur, cloth, hair, animals, with fur, obviously, human hair. If you're doing your shots, the layout, the animation, simulation and FX. We were talking earlier about simulating bombs, being able to do the physics behind an accurate explosion and then render it accordingly, adds a degree of veracity to a video that simply couldn't be achieved by turning the explosions over to an artist. The other important thing to note, obviously, is you can scale performance. If a single GPU won't do the work, you can assign 2. If 2 won't do it, you can utilize 4. If 4 won't use it, you can utilize 8. So Quadro RTX, is very important to note, has been certified by NVIDIA for use in the data center in servers. Quadro RTX is the only Quadro graphics card, specifically the RTX 6000 and 8000, that are approved for data center deployment. So if you want to build a very large rendering farm that meet your simulation needs, you could do it with much more economy than prior generation Pascal products and much greater economy than a CPU-based solution. Part of the reason this is so is a high-speed interconnect called NVLink. NVLink lets you connect Quadro RTX 5000, 6000, or 8000 cards and pool the memory on the cards, pool the CUDA cores, the RT cores, the tensor cores for AI to realize better performance, and do it at significantly higher speeds than PCI Express enables. So better performance by lowering latency, better performance by increasing the amount of GPU memory available to your simulation, and by bringing additional CUDA, tensor, or RT cores to the task. Now, if you look at rendering, and here I'm going to talk Hollywood because, when you talk cinematic quality, that's what they're in the business of doing. If you're looking at an average shot, it requires today, if you're using ray tracing, on the order of about 34 gigabytes of GPU memory to realize the full performance benefits of ray tracing with a GPU. That's because the entire model, the geometry, the textures, the lighting, has to fit into GPU memory. At the high end, that can go as high as 75 gigabytes, and since these folks are never happy, these numbers are probably creeping upwards since I created this slide. The fact of the matter is the Quadro RTX 6000 with 24 gigs, the RTX 8000 with 48 gigs of GPU memory can meet these needs. In the case of the 6000 using NVLink, in the case of the 8000 for the edge case example, 75 gigs using NVLink to give you 96 gigabytes of available GPU memory. The performance implications are dramatic, but the economic implications are also extreme. Again, I talked a moment ago about a rendering server. Let's say you're deploying a rendering server as part of your simulator. You see a rack full of CPUs, entire row of them, in fact. That can be replaced by 4 8-node GPU RTX 8000s at a quarter of the cost, a tenth of the space, and the 11th the power. So think about the implications of delivering the entire solution, the entire economics, the total cost of ownership over the life cycle of the simulation or training environment. And Quadro RTX GPUs can deliver a tremendous and very compelling economic advantage. Now let's shift gears and talk about artificial intelligence and what it can do in a graphics context. One of the key things to understand about NVIDIA RTX is we're not just selling you a graphics board. You're also buying into a very rich, very broad, very deep ecosystem of software development kits and APIs for integrating AI features into visual computing apps like simulation and visualization. NVIDIA calls this NGX, Neural Graphics Extensions. NVIDIA actually goes in and develops an AI model. One example I'll show you is a technique called infill, where you can take an image that's really been defaced and through AI restore it to pristine condition. They train the deep neural networks required to do that. They deliver to the application developer the AI model and the SDK. The application developer from a much higher level can integrate AI through the SDK into their application. And when they install the latest NVIDIA driver, they also get the latest AI model and then can present NGX-aware applications and the features to users. And I'm actually going to demonstrate some of those. One is upres. One of the issues you may face is you have some images that are relatively low resolution. You want them to look better. Well, in the past, without AI, there were techniques like nearest neighbor or bicubic filtering that did okay jobs, but quite frankly, they're kind of meh. I own a 4K TV. I'm sure some of you do as well, and you've occasionally noticed that the scaling leaves a little bit to be desired. AI SuperRes actually uses a trained deep neural network to go and evaluate the entire image and literally create new information based on its understanding of the structure and texture inherent in the source image. And if you look at this cat face example, particularly the whiskers above the eye and the cat eye itself, look at the nearest neighbor approach, look at the bicubic filter, and look at the difference in AI SuperRes. It's not subtle. It looks real with the AI assist. It does not look real when done with the traditional methods. Another issue you may encounter is you've shot video, but for training purposes, you'd like to show it in slow motion. I'm going to show you a brief snippet that was shot at 30 frames per second, and then through, again, NGX and a deep neural network, we're going to move that up to 120 frames a second. So here it is at 30. Very quick, very brief. Here it is at 120. And again, this wasn't a second shot or a second camera, which would add quite a bit of cost. It was simply taking the source 30 frames per second video and using AI slow-mo to generate the additional data. Quite often, you may have images that you're going to use in the simulation, but they contain extraneous elements that you may not need. So NGX AI in painting, I like to call it a magician. If you've used Photoshop over the years, as I have, I'll date myself. I actually beta tested Photoshop back in 1987. I'm very familiar with the healing brush, but what if you could use a deep neural network to do the heavy lifting for you? So we're going to get rid of Surfer Guy and his girlfriend. At first, it looks like the healing brush. I'm just blotting out what I don't want. The AI went in and did the hard work of infilling it with what looks like accurate sand and accurate ocean, something the healing brush simply could not do. What about VR? VR is, in a lot of training environments, really coming to the forefront. And Quadro RTX can deliver a better VR experience than any competing graphics card. One of the reasons are new shading technologies. Variable rate shading can do things like match the lens optics of a given head-mounted display so it can fully express the quality it's inherently capable of delivering. Another feature is foveated rendering. The fovea is the region of the human eye that is most visually sensitive to resolution, unlike peripheral vision, which is more attuned to detecting motion. So foveated rendering and eye tracking can always place the highest visual fidelity where the fovea, the portion of the human eye that's most sensitive, requires it. It places the detail where it's most needed. Single pass stereo makes very efficient use of GPUs for VR because it can actually, in a single GPU pass, use the same geometry but generate up to 4 independent fields of view. It can also let you do very wide field of view in head-mounted displays that approximate that of the human eye-brain system. So peripheral vision, just as in reality, is what you'd experience with your VR HMD, all with at the same time having the extreme fidelity, visual acuity of foveated rendering. Now, finally, Virtual Link makes it easier than ever before, and Quadro RTX supports Virtual Link. So a single cable can now handle all the communications, all the data, all the video back and forth between an HMD and a graphics card that in the past required 3 or potentially even 4 cables. And the ultimate result of all this is better performance through optimized rasterization using advanced shading technologies, ray tracing with the RT cores that are unique to Quadro RTX, directional audio If you're simulating and acoustics as part of the environment, the RT cores can also be used to provide directional audio. You can even assign a single Quadro card to each eye, one to the left eye, one to the right eye, something we call dual input VRSLI. Virtual link. It makes it much easier to connect a Quadro RTX card to the latest head-mounted displays. A single cable provides DisplayPort, 27 watts of power, and the signaling information that needs to go back and forth between the HMD and the graphics card as the user changes their position or point of view within a virtual environment. All of that's handled over a single cable, supported by NVIDIA, Valve, Oculus, AMD, and Microsoft, among others. NVIDIA is going beyond, though, just simply the visuals and the audio of virtual reality. Their Project Holodeck technology is actually being turned into an SDK. We don't quite know when it will be available or on market, but it not only provides VR, but it allows for multi-user avatars to interact collaboratively with a virtual reality environment. So think of it, if you will, flight training, where you have a pilot, a co-pilot, you may have, the instructor, all participating in the same virtual cockpit environment in real time. Obviously, one of the key things to make that happen is GPU-accelerated artificial intelligence, both for rendering as well as helping come up with the context that you may want to present in the simulation environment based on past occurrences. So keep an eye out for holodeck technology, already been shown publicly and will be coming to a Quadro RTX product to aid your development efforts soon. Another very important feature of Quadro RTX, which is essential for VR in simulation, is a tremendous amount of GPU memory. The RTX 8000 has 48 gigabytes of GPU memory, the RTX 6000, 24 gigabytes. The only card that comes close to matching it is the Quadro GV100, which is a prior generation Volta architecture card, or NVIDIA's own Titan RTX. But the 8000 simply creams all the other cards. And with NVLink, effectively, you could take that up to a full 96 gigabytes of GPU memory. Now let's talk a little bit about the RTX products. The RTX 8000 is the very top of the line. It is the uber card and the most powerful graphics card NVIDIA knows how to build today. 4,608 CUDA cores, 576 Tensor cores for AI acceleration, 72 RT cores for ray tracing, 10 billion rays per second. AI, 130.5 Tensor teraflops. Incredible numbers. Back in my days at Apple, even when we had a Cray supercomputer, it didn't begin to come anywhere close to what the single graphics card is capable of delivering. Memory is also very fast at 624 gigabytes per second, so maximum memory bandwidth. You have NVLink support, so 100 gigabytes per second bidirectional communication between dual Quadro RTX cards for performance scalability or increasing simulation complexity. The RTX 6000 actually has the exact same GPU as the RTX 8000, so you won't see any differences in the performance numbers it puts up, but there is a key specification difference, and that's that it's a 24 gigabyte card as opposed to a 48 gig. So 24 gigabytes of GDDR6. I should mention all Quadro RTX cards offer optional error correction code memory, so if that's a feature you need, you can turn it on or you can turn it off as needed. You still get the 10 gigaarrays per second, the same 130.5 Tensor teraflops, the same NVLink support. When we show you the 6000 graphics performance, up to twice as fast as the prior generation products using spec ViewPerf. I'm going back Gen -2 to the M6000, Gen -1 to the Quadro P6000. It varies. The geo mean was almost 2x, 1.75, which is a good number to take away from this slide. When it comes to the competition, AMD has a card, the WX9100. It doesn't have RT cores, no real-time ray tracing, has no tensor cores, no AI acceleration to speak of, And if I normalize its results to 1, you see up to 3 times the performance utilizing Quadro RTX. So realistically, if performance is your ultimate goal, NVIDIA can deliver far more than our friendly competition in Santa Clara. Both companies are headquartered in Santa Clara, can deliver. The RTX 5000 does take the CUDA core count down a little bit, the tensor core count, the RT core count down, but can still deliver up to 8 billion rays per second, and with almost 90 tensor flops, still deliver the AI assist to cause those ray trace renderings to, through a DMN, snap in after just a few iterations, as opposed to hundreds, which are typically required when doing ray tracing. Quadro NVLink is still supported, 50 gigabytes per second bidirectional in this case, 16 gigabytes of memory. As you look at the Quadro cards from a visualization and simulation perspective, the question you should ask is, how much GPU memory do I need to have my model fit, my environment fit in? And use that to choose the best card, because to get the full benefits of GPU acceleration, your model does need to fit into GPU memory. If we go down to the RTX 5000 in terms of performance, still tremendous improvement over previous generation offerings, either the M5000 Gen -2 or the P5000 Gen -1. In terms of geomean, again, this is an average. It could go as high as 2.39, but if I look at geomean, about 1.75 times as fast. Again, if I look at the competition and I normalize the WX 8200 and the 9100, I utilize the 8200 to 1. Oddly enough, in some cases, the WX 9100 is actually slower than the 8200. The Quadro RTX 5000 is significantly faster across the board, again, using spec viewport. The RTX 4000 is a single slot width card, something you may want to bear in mind based on your system enclosure. Also has a much more liberal power budget, 125 watts if you're not using VR, 160 watts if you are. But still has the RT cores, the tensor cores for ray tracing and AI acceleration, 8 gigabytes of GDDR6 ECC. So you're giving up 8 gigs of memory relative to the RTX 5000. The other thing you're giving up is this card does not support NVLink. But the fact of the matter is, with nearly 60 tensor flops of deep learning performance and 6 billion rays per second cast by the RT cores, the world's most powerful single slot graphics card is eminently suited for simulation and visualization use cases. Again, spec viewperf is the performance metric of choice. A little over 3 times faster than the prior generation. I'm going Gen -1, Gen -2. Geomean is a good takeaway to look at, that if you're doing medical, if you're doing VR, many medical schools now are using simulation rather than cadavers to teach students basic anatomy. You'll see over 3 times the performance. If I look at the competition again, up to 2.84 times faster. The simple fact of the matter is Quadro continues to enjoy a performance advantage over any GPU that AMD can ship. Why Quadro versus GeForce? I mean, the fact of the matter is you can go out and buy an RTX GeForce card. You can go out and buy a Quadro RTX card. Well, Quadro is designed for workstations. It's tuned for professional applications and workflows. It not only has the performance, but it delivers the kind of stability you need in a simulation environment. If your game drops a few frames or it crashes, you simply restart or you ignore the drop frames and you keep playing. If your simulation starts dropping frames, your simulation is effectively ruined. If your simulation crashes, you may need to put people through a rather complex process to bring the system back to a state or reacclimate them, let them go through the simulation again to reach where they previously were. Quadro delivers a degree of stability that GeForce is not designed or intended to provide. There are a lot of reasons for this. Here are some of the key ones. The first is enterprise-grade reliability. A little known tidbit about Quadro, they actually employ more software engineers than they do hardware engineers. Much of that engineering time and expense goes into the drivers NVIDIA distributes with their graphics card. Quadro enjoys what are known as long lifecycle drivers, or optimal drivers for the enterprise, or another name they go by. These are drivers that have been rigorously tested for long lifecycle deployments, which in a simulation environment is a big deal because you don't want to constantly have to be tweaking the entire simulation system simply because you dropped a new driver into it. With Quadro, you simply don't have to do that. We have a driver roadmap, just like there's a hardware roadmap. We give you advanced notification of upcoming drivers. If you want to do testing, see if they're advantageous, fine. If they're not, stick with the driver you have. We have ISV certifications. There are already 100 professional apps, many of them which fall in the visualization ecosystem and simulation ecosystem that are certified for performance and stability with Quadro. And they're tested with all leading system brands, such as the systems built by Dedicated Computing. Clearly, when it comes to workflow acceleration, the whole professional application focus means a very different set of tools than when you're just playing a single game. And simulation and visualization environments need to be managed. So Quadro provides the IT tools down to the driver level, the firmware on the card, to enable IT to, or for that matter, the operator, to quickly and easily diagnose problems should they arise, a capability that's simply not available with GForce. So Quadro is the right choice for today's cinematic quality, ray tracing enhanced, AI enhanced visualization and simulation environments and use cases. It has the mission critical drivers, the ISV certs, the pro application performance, the scalable performance with the large amounts of GPU memory and NVLink, the IT management capabilities that are required to seriously consider deploying these in mission critical government or enterprise contexts. So when you consider the points made on the previous slide, Quadro RTX really is the right choice for professionals. We have the mission-critical drivers, the ISV certs, folks like Dedicated that certify them for use with their systems. You have workflow acceleration for professional applications, the feed system of apps that help you generate the assets required for your visualization or simulation environments. And you have the IT management and configuration tools that governments or enterprise players would require for such a mission-critical deployment. That's my portion of the Quadro RTX presentation. I'd now like to turn it over to our partners at Dedicated to close out this presentation.
Carl, thank you. Thank you very much. Really, really informative. I got a quick question for you. You mentioned you beta tested the Photoshop application. I found that very entertaining. Do you remember?
Back on a Mac.
Yeah.
A Mac 2.
Oh, a Mac 2. I guess the Mac 2
with an 8-bit graphics cards. So,
well,
yes.
By the look of that editing on that beach scene, I've been using Photoshop for over 25 years, and that would still take me probably an hour to do. So, pretty cool. All right, that concludes this webcast. Thank you very much. If any of the audience members have questions or comments or feedback, they can contact either Jeff, Carl, or myself directly. There's our emails on the screen. And we did have a little bit of glitch with some of the video clips, so I will likely make those available on the website as a follow-up to this. So, Carl, Jeff, thank you again. Appreciate your input and expertise. Have a good day.
Thank you all. Enjoyed doing it.